Hello guys, welcome back to our series on ESP32 using ESP-IDF. So today's video will be a detailed video on Sdkconfig, how it is generated, how to configure ESP-IDF using Sdkconfig, what is kconfig. Also, I will tell you how to write a kconfig file. Let's get started. So you must have seen these files like Sdkconfig.default.rename, .old, .cmake, .json, .ci, and you must have noticed Sdkconfig and kconfig.projbuild. So let us start first with kconfig, which is used to generate these Sdkconfig files. So kconfig is a language which was developed to configure a custom Linux kernel. So if you want to build a custom Linux kernel, and if you want to configure it according to the features and modules that you require, then this kconfig file is used. So same concept they have used in ESP-IDF. And using this kconfig file, our Sdkconfig file is generated when we build any project. So there is a kconfig file for every component. For an example, let us take a partition table. I'll open this file, and here we will open the Sdkconfig. And so here, if we go in this partition table, offset of partition table will be there in this. This is the configuration, and this is the rationale for this configuration, offset of partition table. If you have your own component and you want to add your component configurations in this Sdkconfig file, for that we have to write a kconfig file like this. Before writing kconfig file, I have written here kconfig and kconfig.projbuild. What is the difference between these two? This is the kconfig.projbuild file. So in that case, your configuration will be displayed in here. If your file name is only kconfig, then your configurations will come under this component config. If you expand this, see this Bluetooth you can see here. So first let us create a component. I have already created a component for testing SDK, and I've also prepared a kconfig.projbuild file here. So this is my kconfig.projbuild file, and I have already built this Hello World project, and you can see this testing SDK. So you have to start with writing the menu. What will be your menu name? So these are the keywords: menu, config. This is which type is this? If you are having a range, if this is integer, it is between the range of 0 to 100. Default, what should be a default value? All these are the keywords. The kconfig keywords can be divided into two groups: entries and options. Entries define basic structure of the configuration itself, and individual configuration options. Option further specifies the entry. So entry is menu. Inside menu there is an entry called config, and inside the config you have written this bool, int, string, right, help. So inside the entries there are options. I have not covered everything here, but I have covered most of the configurations that are usually used. So this is menu. It is the keyword, entry keyword. Menu testing SDK. You can see here testing SDK. Under testing SDK, what is there? Bool option test. Okay, I have configured a bool option. This is the type, that is bool. Bool option test is this is the string that will be appearing in the Sdkconfig file, the GUI that we open, and default it will be true. Means this bool config options, this option will be enabled by default. So if you see, it is tick by default. Second is int option test. Suppose you are having a configuration of integer. So config int option, it is int option test. This string will appear in the Sdkconfig GUI, int option test. And what is the default value? It is 10 here. So range I have given from 0 to 100, and my default is 10 if bool option is enabled. Okay, so bool option is here true or yes. If this option is disabled, then default value will be 28. Third is hex option. It is similar. This option is depends. Depends means depends on bool option. Means if bool option is enabled, then only this hex option will appear. So we will disable it by default. Now the bool option is enabled, so it is visible, the hex option. Okay, the hex option text, it is visible here. If I disable this and build again, then I will not see this option. String option. Similarly, if you want to define a string, this help is our option here. This question, if you click here, it will tell you the option is used to test string in kconfig file. What I have written here under help, the option is used to test string in kconfig files. We will see this one later in this video. Source option. Now the next is choice. Choice is an entry keyword for kconfig. This is also a bool because only any of the one choice will be selected. So this is in conditions where you have four options, or you want the user to set only one option out of these four. Not all four can be set. In that case, the choice is used. Okay, your first choice is set. If I click the drop down, there are two choice one and choice two. See, choice one and choice two, as I mentioned here. In preview, if we see, choice one is true only, and choice two is not set. Right. So this is comment out. Now, how to use this or any of this if you want to use? So all these are kind of hash defined macros, and these are defined in the sdkconfig.h file, which you can see under build config, this sdkconfig.h file. All these are hash defined here. So if I search, see, these are our user custom defined configurations here for our component. So now how to use these configurations in your code is, first you have to include this sdkconfig.h file. Is already included here in our, we are considering the hello world main.c. Now suppose I want to print something only if this config bool option is enabled. So here I have already written it. So if config bool option is true, then only I will print this, and I will end the if. So using this hash if directives, we can write a condition for this bool options. Second example, we will just take about the int option. So this can be used as a default value of any variable. Suppose here I have defined a variable, temporary variable, and I have assigned this value to it. These configurations can also be used in your component file. If you are writing some code in this .c source file, then these options can also be used here. So this is all about kconfig. So let us understand about this Sdkconfig, all the different files, and why esp-IDF has provided all these files. So let us start with Sdkconfig.default. So this Sdkconfig.default file is basically used as a default configurations for your new project. So suppose you are having project 1 and project 2. So in project 1, you have suppose made some changes, and you want the same changes as a default in your second project as well. For example, now suppose this is my Sdkconfig file. Now here, these are my default configurations, right? I have not changed whatever the configurations they are there in the kconfig, as it is default configurations are done here when I build the hello world code. Now suppose I change this to 20 and I did some more changes, 10-15 changes, right, in this configuration, and I built the code. Now the new changes will be reflected in this SDK config. Now suppose I have to use this same SDK config changes in my new project that I create. So what I have to do, I have to manually check every change here, what change I have done, and I have to do it there. So to overcome that, the ESP-IDF has given a Sdkconfig.default file. In this Hello World project, I will generate the Sdkconfig.default file, and I will pass the same file to the new project. And when I build it freshly, it will not take the default changes from this kconfig file. It will take the changes from the Sdkconfig.default file. Now let us test this by an example. 25. Okay, I change the string to hello world. Okay, and I change the choice to 2. I will save it and build this hello world project. So our build is completed here. How to generate the sdkconfig.default file? For that, there is a command provided by ESP. Just go to your project and open the command prompt and enter this command. I will paste this command in the description. So this is Python idf.py, and this is the command save def config. So our sdkconfig.default file is generated here. Only the changes that we have done are visible here. Okay, rest all will be the default changes that will be taken from the kconfig file. While executing this command, you might encounter some errors. For that you have to add a few paths in the environment variable, and you have to add these 3 paths here. I will paste the path in the description of this video. Now here we will create a new project. We'll name it as hello world underscore one. So a new project is created. There is no SDKconfig file here. In hello world, we have created a Sdkconfig.defaults. We will just copy this file in hello world one. We'll paste it here. Now let us build. So our build is completed. Let us see the Sdkconfig file. So it is taking these default configurations from the Sdkconfig.default file, and rest of these configurations are taken from the kconfig. Now let us see Sdkconfig.default.esp32. So this is also called a target specific Sdkconfig default file, where your target can be the controller that you are using. It can be ESP32, ESP32 S series, ESP32C. So now what is the use of this? This is a GATT server example. You can see these are the target specific Sdkconfig default file. So why target specific? Because in some controllers you might be having different memory, or suppose like ESP32 is having Bluetooth and Bluetooth low energy, but S3 is only having Bluetooth low energy. So there are different configurations depending on different controllers. But to take the configurations from this file, you need to have sdkconfig.default file compulsorily. If you don't have this file, then these configurations will not be picked up during the build. So let us take an example of this. Now in my workspace, I will take two targets per configuration file. One is this. I will paste it here and I will rename it as defaults.esp32s3. And second target, I have built this hello world using ESP32C3. So I will just copy this SDK config from hello world and I will paste it here and rename it. So these are my two target specific file. Now let us open these into a notepad and we will change some configurations. Suppose ESP32C3, I will keep this option int option as 99 and I will save it. And for S3, it is kept as 5. So this change is to be done. Here we will change the target to C3. This is important. Here the target is ESP32C3. For ESP32C3 SDK default config, and for S3 default config, the target is S3. So the ESP-IDF build will pick which default configuration, target specific default configuration to use from this target. So I am building hello world 1 for ESP32 S3 as a target. So you should delete your Sdkconfig file before building this. If you can see the log, the configuration done is here. So what is this configuration? It will generate the Sdkconfig file here. So if you can see in build, see these configuration files are already created before the build starts, because that is there because you already include this Sdkconfig in your project. So if this file is not there and if you are building, then it will give an error. So always the configurations, these files are generated on every build and then your actual code compilation starts. Now our build is completed. We'll check what are the configurations that we have got after the build. See, our int option test is set to 5 here. Int option is set to 5. We'll change our target to ESP32C3 and now we'll build again. See, as you can see here, int option test is 99. For ESP32C3 Sdkconfig default, it is 99. Now next is Sdkconfig.rename. So as the file says, rename means like in our kconfig. Suppose I rename this bool option to bool option test. So this rename is basically used by esp-IDF only as a part of each component. If you are changing the name of any configurations in the kconfig file of a component, then you have to add a rename Sdkconfig.rename file there, so your component can be used as backward compatible. For an example, so let us see a Sdkconfig.rename file. So these are my old or deprecated configuration name that I have used in some previous version of esp-IDF, and in the new version of esp-IDF, the name are replaced with this. Sdkconfig.rename files are created and maintained by the esp-IDF developers itself. We as application developer, we don't have to bother about this. So let us say practical example. So this is our component. Now I will add a sdkconfig.rename here, but before that, this is our kconfig file of our component. So I will change bool option to bool option, suppose test, int option to int option test. Okay, I will save this file. So now we have to give a sdkconfig.rename file. Copy this and paste it here, and we will modify this. Okay, so hash, these two are comments. So this is how our sdkconfig.rename file will look. Save it, and we will build the code. Here you can see the config bool option. This is the old configuration name that is still working. Now let us open the SDK config. In preview, we will search for the bool option. So this is the new configuration name, bool option test, which is under testing SDK. And here you can see config bool option, that is the old configuration name, is also mentioned under deprecated option for backward compatibility, line number 1823. That is the reason our code is working even if we define the old configuration. There is one more configuration in sdkconfig.rename. It is specific for the bool variable. If you add this exclamatory mark here, this means that you are inverting the bool configuration in the deprecated configuration. So it will be inverted, the old and the new one. If this is true, then the old one will be false. If this is false, then the old one will be true. Now the next one is sdkconfig.old. So as you can see here in hello world, there is a sdkconfig.old file created, and in the hello world one, there is also sdkconfig.old file created. The sdkconfig.old file is a backup of the previous configuration, and it is generated every time the sdkconfig file is generated. Whenever you make a change in sdkconfig and you build, your sdkconfig is generated, and the previous changes will be reflected in the sdkconfig.old file. And it is recommended that not to manually edit this sdkconfig.old file. The next is sdkconfig.cmake, sdkconfig.json. So if we go in hello world build and this config, these files are here, sdkconfig.cmake and sdkconfig.json. These files are same as sdkconfig file, but with a different format type. Out of this, sdkconfig file can be used in the cmake list, this cmake list. So just to make you understand, we'll open this cmake list, sdkconfig.cmake. So like for example, just copy this, and here if this configuration is true, do something here else. So in this way you can use this sdkconfig in the cmake list, and you can configure the cmake list as per your use case. Now the last one is sdkconfig.ci. So you can see here sdkconfig.ci file. CI means continuous integration. So this file can be used in the CI/CD pipeline. It is commonly used in Jenkins as a stable build configuration for ESP-IDF projects. If you find this video helpful, do like and share this video, and don't forget to subscribe our channel. Thank you.